Okay, thank you. All right, now we are going to, this is one of my favorite weeks. And I hope by the end of it, you're going to see that, oh, this is pretty cool. Because we're going to talk about conic sections. I'm even going to explain what that is. Okay, so let's go back and review just a little bit. All right, this is what we worked on synthetic division. Now, synthetic division is what you have to start with when you are factoring a large polynomial. Like if this was my polynomial and it starts with a 1x to the fourth or 1x to some power, then you can use synthetic division on it if you want to try to find the binomial that will go into it. Now, the other skill that goes with that is the remainder theorem, because you test by putting a value that you think is possible into this equation, looking for a remainder of 0. Once you get the remainder of 0, then you can use synthetic division. Now, if you'll notice here, I ended up with 2 minus 2, which is 0. But I already knew that when I started. Okay? And that's where the remainder theorem from chapter 6, no, I'm sorry, chapter 7, the remainder theorem from chapter 7 and synthetic division, that's where they come together. So when we do this, we bring the 1 down. Some people put an arrow here. That's okay. Whoa. Okay. All right. So 2 times 1 is 2. That goes here. Adam, get 4. 2 times 4 is 8. Put it here. Adam, get 3. 2 times 3 is 6. Put it here. Adam, get negative 1. 2 times negative 1 is negative 2. And I already knew that 0 was there. So, because this was a fourth, this is x to the third, 4x second, 3x minus 1. X minus 2 times that, and then you'd work on that one to try to see if it factored. Okay? All right, now here's another one that I put up, which was not up last week. So this is another example of synthetic division. All right, if I have x fourth plus 2x third minus 5x squared minus 3x plus 14, and I set those up here, and I found out from my remainder theorem that a negative 2 will make a 0. That means the binomial is x plus 2, so that the x is negative 2 to make the 0. So negative 2 times 1 is negative 2. Add them together, get 0. What is negative 2 times 0? 0. Okay, so when I put it there and add, I get negative 5. Negative 2 times negative 5 is positive 10. Add these two together, get 7. Negative 2 times 7, negative 14. Negative 14 is the 0 that I knew was there. Okay, so now I have x plus 2, and now this was 4, so this is third. X third plus nothing minus x plus 7. And so those become the two binomials that you would work on. And that's synthetic division. All right, synthetic division is used a lot in the higher algebra. Okay? All right, now we're moving into, and that's teacher notes. Okay, so we're going to be moving into chapter 9. And chapter 9 is the conic sections. I'm going to explain conic sections during this class period, and you're going to see that it is relatively simple. Okay? That's where, and then it also says, now, I've given you test 15, right? I've given you 15, so this test you're going to turn in to me next week. Okay, you're going to turn in 3 if you remember, but this is the one that's scheduled, and that. So now we are up. We've caught up with the week that we missed because I was sick. All right, now here now I'm going to show you about conic sections. Now conic sections. All right, talk about cone. Conic is the adjective of cone. Okay, so technically what they have is two cones set on top of each other at the point. Right? If you take a plane and you cut the cone, you're going to produce a circle, an ellipse, a parabola, or a hyperbola, depending on the angle of the plane that you cut through the cone at. Right? So, if it's parallel with this base, right? If it's parallel with the perpendicular that goes through here, then you're going to end up with a circle. Now, that in itself doesn't mean anything unless you work in a metal shop. Then that would be important. But for us, we are going to have an equation that produces a circle. Right? Now, if I angle it, I'm going to cut through, and it's called an ellipse, or ellipse. Right? And there is an equation for an ellipse. And we're going to talk about those. Now, if I cut it so that it comes down through here, right, and it doesn't cross the midline, so it's basically parallel with the axis of symmetry, I produce a parabola. And we've been working with those, but that's where the parabola comes from a section of the cone that is cut by a plane. Right? And then the last one is the hyperbola, and that is if this thing gets all the way inside and it hits both cones at the same time, then that's what a parabola is. And if I took this thing and rotated it 90 degrees, I could also have the parabola that's going along the x-axis instead of the y-axis. Okay? So these are the four words that are part of the conic sections, and each of them has its own equation. That's what you have to learn, is what does the equation of a circle look like, what is the equation of an ellipse, what is the equation of a parabola, and what is the equation of a hyperbola. All right, if you learn all those equations, then all this is easy. Don't learn the equations and the differences between them, and this is hard. Okay? All right, I still see. Now you can get this picture. I pulled this picture off the internet. All right, you put in conic sections, right, and then go to images on your search engine, and you'll find a picture. Both of these pictures are off the internet, so that they're not hard to find. Okay, all right. So let me move on so we don't lose time. All right, we're going to come back to that. Okay. Oh, never mind. I know where it is. Here. Point. All right, now. All right, so this is the formula for a parabola. Now let's look at this example. This is what you're used to seeing. Y equals x squared minus 6x minus 5. All right, that would be a parabola. Y. What's the thing that you notice that causes you to understand that this is a parabola? Right? It has an x squared here, but the y is y to the first power. If I gave the y squared here and an x to the first power, I would have a parabola that instead of going like this, would be going sideways. Okay? The open end points toward the positive when this is positive. The open end points toward the negative when this is negative. So if I had a negative 2y squared, then it would be opening to the negative on the x-axis. Right? You don't use those as often because they're not functions. Right? Because it's set up differently. Okay? But anyway, so that's a parabola. So if you were looking at an equation that was out there in general, how do you know that it's a parabola? It has an x squared and a y, or it has a y squared and an x. Both of them are not squared. That's how you tell the parabola. So how do you tell the parabola? When both of them are not squared. Okay, I'll say it again. How do you tell you have a parabola? when both of them are not squared. Okay? So we can get one out of the way real quick. It either is or it isn't, because if you look at the highest term of the x and the highest term of the y, if one of them is squared and the other one is not, then you have a parabola. If both of them are squared, then you do not have a parabola. Okay? So we'll be able to tell this relatively quickly. All right? Now, circle. A circle has both the x and the y squared. Okay? Now, this is the form that we like, but this would be the form you were given. Alright, now, if you'll notice, right, I have an x squared and I have a y squared. Right, so therefore I don't have a parabola, but because both of these exponents, both of these coefficients are 1, they're both the same, therefore I have a circle. Right, now, look at the difference between the circle and the ellipse. Alright, this has x squared, this has 4x squared. This has y squared, this has 9y squared. These two are different. So when I go this way on the x, I'm not going the same value on the y, I'm going more. So when I do it, I end up with an ellipse. If I went the same distance this way as I went this way, I would have a circle. Alright, does that make sense? Okay. So, how do you tell the difference between a circle and an ellipse? Alright, first, they're both positive. They're both squared. The circle, the coefficients are the same. In the ellipse, the coefficients are different. They're both squared. Both coefficients are the same. And both coefficients are positive, and you end up with a circle. They're both squared. Coefficients are different, and they're both positive, and you'll end up with an ellipse. Now, all of this right now is just information because you don't know what you're applying it to yet. Okay? All right, now, hyperbola. And a hyperbola is the one that has two parts. It has a parabola up here and a parabola down there in the opposite direction. And they're either going north-south or they're going east-west. Now, the difference between the ellipse formula and the hyperbola is this is plus and this is minus. Right? They're both going to have an x squared. They're both, the coefficients are going to be different. So right now, these two are tied because they both have x squared and the coefficients are different. However, the signs, this is positive. Uh-oh, I did it wrong. Didn't change that, did I? This has to be negative, so I better change it before I forget. Why didn't it work? Okay. Now the signs are different, which is the third thing. The signs are opposite. So this one's positive, this one's negative, or if this one's positive, that one's negative. Okay. So, how do you tell a circle? Both squared, both coefficients are, say the same. The same. Alright? How do you tell a circle? They're both squared, both coefficients are the same, and they're both positive. Alright, how do you tell an ellipse? They're both squared, they're both positive, but the coefficients are different. Alright? Hyperbola, they're both squared, the coefficients are different, and the signs are different. Right? Okay, so those are the definitions. Right now. Alright, so let's look at a couple. Alright, what do you see here? Look at, are they both squared? So therefore, it's not a parabola. The parabola only has one of them squared. All right, what do you notice about the coefficients? This is a 4 and this is a 1, so they're different. All right, so therefore it's not a circle. Because in a circle, they're both the same. The coefficients are both the same. So now, the signs are both positive, so that's an ellipse. Had one been positive and one been negative, that would have been a hyperbola. All right, so look here. What do you see? Both squared and what? Both coefficients are the same, so what is it? It's a circle. And then what you would do is that you would have to complete the square. Because this is 1, you're going to take half of this, right? So it's going to be x plus 6 quantity squared. And then for this one, you're going to take half of this, and it will be y plus 3 quantity squared. Right? But it's going to be a circle. Right? Now, next one. What do you notice? X squared or x? X is first power, y is second power. So what is it? Starts with a P. It's a parabola. Right? Can't be a circle because they both have to be squared. Cannot be an ellipse because they both have to be squared. Can't be a hyperbola because hyperbola, they both have to be squared. And so because only one of these, that's a parabola. Now, this one is set up going sideways. Because this is positive, it's going to open to the positive on the x-axis. Normally we see this as x squared and y because that's the ones that makes the function. Okay, what do you see here? Both squared, right? But, what? The signs are different, so it has to be hyperbola. It has to be the last one. The hyperbola is the only one that has different signs when they're both squared. Okay? Now, the form, and we'll get into how the form's created a little bit. The center of whatever this is x minus this, so it'll be -5, 3. -5, 3. Now, here's the thing that's cool. Square roots of both of these numbers. This is a 4, this is a 3. So we're going to actually construct from this center of -5, 3, we're going to go 4 in the x direction, and we're going to go 3 in the y direction, and we're going to make a box. Hey, come on in, come on in. Glad you made it. You okay?
Yeah.
Okay. All right. Now, what do you see here? All right. This is a y, right? So the x value is 3. And the y value is 1, so 3, 1 is the center, and we're going to go 4, and that was supposed to have been 49. See what I did on that one? I was thinking 7, and I wrote the 7 instead of the 4. So this will go in the y direction. From this center point, it will go up 7 and down 7, and then in the x direction, it will go 6 this way and 6 this way, from 3, 1. Okay? So we're starting. Now let's look at the last one. Alright, what is this? Alright, both squared, right? Both the same sign, but this has a 4 in each direction, and this has a 9 in each direction. The 4 is in the x direction, so the center of this is plus 0, plus 0. Okay? So what happens, and I'm gonna start with this one graphing. Okay, let's see if I can't remember if my graph is on the other page. Okay. So that was x squared plus y squared over 16 and over 81 equals 1. Okay? Now, this center is at 0, 0. It goes here. Now, whether or not you have a parabola or you have an ellipse, you are going to make a box. So this direction goes 4 in either side of this. Because that's at 0, 0, I'm going to be at 4 and negative 4. Okay, what would have happened if I would have been up here? I would have gone 4 in this direction, and 1, 2, 3, 4 in this direction, and my box would be formed around this center. But because this is 0, 0, I'm at the origin. Okay, does that make sense? Now, all right, I go up and down, I go 9. And unfortunately, let me change this because I don't have enough room. So let me change this to 49. So I go 7. All right, now, what I'm going to do is draw a box. Whoop, missed it. Okay, now, what do you notice about that rectangle? It's very general. It's taller than it is wide. Right? Now, if this is positive, you're going to draw an ellipse that touches here, 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 and here. Missed it. All right, that's an Easter egg, not a real good one, but you get the idea, right? Okay, so now, if this is minus, you're going to draw the same box. But instead of drawing the box, you're going to draw the diagonals going like this. Okay, now let's pretend this is negative. So now, because the signs are different, this is a hyperbola. Okay? The hyperbola will be along the x-axis. So what I'm going to do is I'm going to go to this point, and now I'm going to go and I'm going to use those diagonals as asymptotes. I'm going to approach them but not cross them. Okay? So this becomes a hyperbola if this is negative. And if this is positive, you're using the same box, you draw the ellipse inside. Okay? Now, for conic sections, that's the simplest presentation on how to take the equation and relate it to a graph. Okay? Alright, so now let's look at one that's already done, and let's see if we can learn or observe some. Let's see here. No, it's on the other one. All right. So, what do you see here? All right. The center is right here. Okay, what is that center? It is 3, it's 0, comma 3. So it's x minus 0 and y minus 3 squared. Because that's how you find the center. Okay, and this we've been doing this for a number of problems. Okay, now, what is the length from here to the edge of the box? It says it's 2. And it's 2 back here, and 2 squared is 4. Right? Now, how far is it from here down to this? It's 3, right? And 3 squared is 9. Alright? Now, if you were doing an ellipse, this would be a plus. And you would draw the ellipse right there. But this is not an ellipse, because this is a minus. And so instead of doing that, you draw the diagonals around that same box, and then from this point, you draw your hyperbola, which is like a parabola, that begins to approach that diagonal from either side. So you come here. Now this is relatively wide. This thing is going to be relatively flat, but it's still going to have a curve to it. Does that make sense? Okay. All right, questions about that? All right, you see where the center comes from. What happens if this is a plus? Then it's y minus -3, and so instead of being up here, it'd be down here. Okay, now, let me raise this up just a little bit so that you can see that. Now, when you see, for our purposes, we're not getting as deep into this as we could. There is a focus point that's right here, and a focus point that's right here. And technically, the distance from this point to the focus out to the curve is the same. Right? And there's a way to actually find it. Right? In this particular case, it would be at 5, so it would be over here. The focus point would be here, and -5 would put it here. So the same distance here to going back. That's how it's made. But we're not worried about that because it's already going to be made for us. Okay, so look at this one. All right, what's the box going to look like? Square root. 4 along the y and 5 along the x. That's where there's your box. Okay, because this is negative, I'm not going to draw the ellipse on the inside. I'm going to draw the diagonals. And then, because the y is first, that means I'm going to come through this point and bring this thing as asymptotes along these diagonals. Okay, does it make sense? Okay, now, for conic sections, that's relatively all that you need to know in order to compare the equation with the graph. All right, now let me go back and let's look at another one. Okay. Now, so if I give you x minus 2 squared and y plus 3 squared, what can you tell me? What do you know? There's a major point located where? Well, positive 2, negative 3. There's a major point at positive 2, negative 3. That's right here. There's a major point. Now, if this were a circle, these two have the same coefficient. It's 1. Right? And if r is 49, this is the square of the radius. So what's the radius? 7. So from here, I go 7, which puts me there, and coming back 7, which puts me here. Going up 7, 1, 2, 3, and 4, and going down 7 will be off the page. And now I'm going to center a circle around that center. Okay? See? So, because these coefficients are the same and they're both squared, I have a circle. And then the radius is the square over here. Right? Now, if this is 4 and this is 6, I don't want 6, I'm going to use 9. And this is 9, and this is 36. Now here's the difference between are these two the same, the coefficients? No. So what I end up doing is I end up dividing by 36. When I divide this by 36 and this by 36, this becomes 9, and this becomes 4, and this becomes 1. And so my x value is going to be the square root of this, which is 3, and my y value will be the square root of this, which is 2. And so my box, which sets at 2, negative 3, will have an x direction of 3 and a y direction of 2. And so my box looks like that. Okay, now, on your paper, draw that box. Just make a box that looks like a rectangle that way. Yeah, I'm gonna clean this up just a bit so that we understand what we're looking at. Now, if the sign in here were positive, you would draw an ellipse inside that box. So do it. Draw the ellipse. Doesn't have to be perfect, but people can get the general idea. Huh? If the sign in between, if the sign in between is positive, we draw the ellipse inside the box.
I didn't see the sign in between.
Okay. Yeah. All right. Okay. All right. Now, if the sign is positive, we're going to draw an ellipse inside the box. Okay. Doesn't matter. All of this is the same between the hyperbola and the ellipse. Right? The only difference is going to be what the sign is here. So the same major point is going to be there, and these square roots will produce the same box. Right now, to draw the hyperbola when this is minus, now the hyperbola is going to be on the x-axis, whichever one is in front. So therefore, I want this point and this point. Alright, what else do I need starting with a D? What else do I need starting with a D? You need the diagonals. So come through here and draw the diagonal. Now, because this is the positive, it's the leading, then I'm going to draw, I'm going to change colors. The focus point, or the bottom of this parabola, the vertex is right there, and this one goes like that. Okay. Now, what would have happened if these two had been reversed and the y would have been first? Then, instead of using these 2 points, I would use the top and bottom. Same diagonal, but I use the top and bottom. All right, question? You've been very silent. All right, so there's 2 basic skills. One is looking at the equation. There's actually 3 skills. One is looking at the equation and figuring out what kind of conic section have I been given. The second thing is being able to draw the box because you use the square root of the number on the bottom. Right? And the third thing is completing the square. Now, completing the square, because I know that when you get to conic sections, you have to complete the square. When I teach Algebra 1, that's one of the skills that they have to be able to do, and they have to be able to do it well, because you can't do conic sections unless you can complete the square. So, let's go back. I think this is where they are. All right, so let's go back to this. All right, here's my square. Now, this is squared, this is not. Right? So, I'm going to complete the square on the y. All right, how do you do that? You take half of the second term. What's half of this? -1, right? And so therefore, y minus 1 squared is the square part. Now, I only had two values here. The third value is -1 times -1. So because I've added a +1 on this side, I need to add a +1 over here. All right, now, normally, this 281 face here equals 40x. The completing square part is half of this, and then you have to add that third number there. Okay? All right, now let's go to the second one. This is where you'd see it if I wanted to make you work. All right, here's a y squared. Okay, first of all, what kind of conic section is this? Tell me about the signs. Signs are different. There's only one that's a sign that has a sign different. What is it? Hyperbola. Hyperbola. Hyperbola is English. Sorry. Okay, so now, so I need a y with this y squared. What is it? Which one is it? I need the 2. So it's y squared plus 2y. What's half of that? 1, right? So it's y plus 1 squared, and my third thing is going to be 1 squared, so therefore I have to put a -1 on this side. Because I've got 3 numbers. I've got this, this, and a 1. Now what about the, here I have negative parentheses, x squared plus 14x. All right, how do I complete that square? Half the 14. What will that be? 7. So this will be minus x plus 7 squared. And I have an extra 49 times -1. So I have an extra -49, so I need to add 49. Now, my third number, which goes over here, is going to be, what, 58? It's going to be a 9. All right, now, because these are different, right, and this equals 9, when I divide by 9, this is 1, 9, and 9, and in this case, what does the box look like? Square root, 3 and 3. Okay, but where's the center of the box? The center is at -7, -1. And so if this is the axis, -7, -1 is going to be here. That's the dot. And then I'm going to go 3 in this direction and 3 in this direction. Because this is minus, I have a hyperbola, and so therefore I need the diagonals. The y is positive, so therefore I want this point, and then I draw hyperbola. Huh? Square root of those numbers. Now, when you read section 9, that's the information that's going to be explained to you. Okay, so because we've done it here, when you read through it, that should make a little bit more sense. Okay? All right, now, let's look, because we've got a little bit of time. It's 10 o'clock. We go to 10:20 or 10:30? 10:25, something like that. All right, now, let me get the right page here. I'm going the wrong direction. Okay. All right, get your books out. And turn to page 462. 462. Okay, 462 at the top. Now what this is doing, first of all, when you look at the x and the y, what do you notice about the x and the y? They're both what? Squared. They're both squared, and they're both positive, and they're both positive 1. So therefore, this is what kind of conic section? It's a circle. Alright, so then the question is, where is the center of the circle in problem 1? It's x minus 0 and y minus 0. Okay, look at problem 1 on page 462. You see that you've added to the x squared, you've added a 0. And to the y squared, you've added a 0. So the center is at 0, 0. Now, what's the radius? The radius is the other number. What is it? It's 5. It's the square root of that because it's a squared plus b squared equals r squared. Okay, now, problem 2, what extra have they given you? They've given you a plus 6x, right? So take half of that. 3. And so, therefore, negative 3 comma 0 is going to be the center of the circle because we've completed the square. Right? Remember, it's the opposite of the number that you get. Right? So, now, what's the radius of the circle? 4. Right? Square root of that. Right? And so, from this direction, now watch. From this direction, if I go 4, I'll be at 1, 0. If I go 4 the other way, I'll be at negative 7, 0. What happens if I go up 4? I'll be at 1, 0. Let's say, wait a minute, I'm sorry. I'll be at negative 3, 4. And if I go down 4, I'll be at negative 3, negative 4. So there's my 4 points around the outside of the circle. Right now. If you look at this, if this is the center and that's one of the points, you can actually see that the distance is from here to here. Right? From here to here is 4, so the distance squared is going to be 16. And that's the number in there. Okay, now problem 3, what did they do? What's the extra number in problem 3? Negative 4y. Alright, so what happens when you take half of that? So the y will be negative 2, so the center is going to be at 0, 2. So that y minus 2 squared is my binomial. And then what's the radius? Now this is a trick. What's the radius? Alright, you've got, when you add the cube, I'm sorry, when you square this, you're going to have an extra 4. So what's 21 plus 4? Equals 25. See the 21 that's there? When you complete this square and have y minus 2 squared, you have an extra 4 that's added here. So if I have an extra 4 on this side, I add 4 on the other side, end up with 25 instead of 21. Okay? So now, square root of this, the radius is 5. All right, now, last one. Last one. What do you see? You see both of them, right? So what's the square root? Or how do you complete the square on the 6? Complete the square on the 6. Take half of it and get 3. So that makes x plus 3 squared. What's my extra number? I have a extra 9, right? And then what about the y? Half of that is y minus 2 squared. What's my extra number? 4. And when you add them together, you get 25. But the center is at -3, 2. Does that make sense? Questions about that? Okay. Now, is that for you, is that something that's hard to see?
Yes.
Right? Okay, if it is, then you need to make sure that you go back over completing the square.
12, 9.
All right, the 12 was given in the problem. Okay, when I took the x squared and the 6x, when I have this, I have 3 terms. I have x squared plus 6x plus 9. So when I take the 2 terms, x squared plus 6x, and I complete the square by taking half of the 6, I've added an extra 9. So if I've added 9 to this side, I also add a 9 to the other side. The other way to do it would be have a minus 9 over on the same side. Okay, now the same thing is here. This was y squared minus 4y. So half of the 4 is 2, so y minus 2 becomes the square, but the trinomial has an extra value of 4. So because I have a 4 here, I have to add a 4 on the other side. All right, okay, so all right, now, so when you're doing 9-2, you've got to make sure that you go through that and that you can handle it. Okay, so turn to page 466. All right, bottom of the page, look at number 1. All right, first of all, how do we know that these are going to be circles? How do we know these are going to be circles? Because they're both squared, they're both positive, and they're both the same coefficients of 1. Okay, so the x is paired with what second term? Minus 10x. So when you complete the square for problem 1, you'll get x minus 5 squared. Okay, that part's easy, right? Now, what is the third term of that square? It is 5 times 5. So if I have a positive 25 that I've added when I completed the square, go to the other side of the equal sign where the 0 is and put another 25. All right, now, second part. What is the y? It's y squared plus 8y. Take half the 8, get half the 8 and get 4. So, parentheses, y plus 4, parentheses, quantity squared, is the y value. Now, what's the third term in that square? It's going to be 4 times 4, 16. So, as soon as you made the completed square, you've added a 16, so on the other side of the 0, put plus 16. Okay? Now, what is the new form that you have? You have x minus 5 squared plus y plus 4 squared. And so now we know the center of the circle is at 5, negative 4. You see that? That's the reason for completing the square, is so that you can find the center of the circle. Now, what's on the other side when you add all those two numbers up? Is it 41? Is 16 plus 25? What's 16 plus 25? 41. So the radius will be the square root of 41. The square root of 41 is somewhere between 6 and 7. Because square root of 36 is 6, square root of 49 is 7, so it'd be somewhere around 6.5. Huh?
6.4.
6.4 something. Okay. Right? And so now that's the radius. So from that center, you're going to go left and right, approximately 6.4, and then you're going to go up and down from the center, approximately 6.4, and then you're able to draw your circle. All right, now, problem 2, which is part of your homework. All right, what happens with the x when you complete the square? All right, Ruben, what do we do to complete the square? Starts with h, we take?
You take half.
Half. So what will the value be when you take half? Half of what is what I'm asking?
30.
No, half of the 12. Half of the 12. So what is half of the 12? 6. So I'm going to have x plus 6 quantity squared.
Would it be 6 or negative 6?
Is it a plus 12?
No, it's minus. Wait, which one are we looking for?
We're doing number 2.
Oh.
Number 2 is plus. So that makes this x plus 6 squared. Now, what's the third term that we've introduced that was not there? It's 6 times 6. So because I have a 36 that I've added, I added 36 on the other side. Now, what about the y for number 2? Half of what? Half of negative 2 is negative 1, so this becomes y minus 1 squared. All right, and what number is introduced? Is 1 times 1, which is 1, and so I add 1 here. Now, was there a value? There was no value, right? So now, where's the center of the circle? Center of the circle is at negative 6, 1. Center of the circle is at negative 6, 1, and the radius is the square root of 37, which is just a tad over 6. What?
21.
I didn't see that, I'm sorry. I'm sorry. Okay. All right, so we have to move the 21 to the other side once this comes alive. All right, when I take the 21 to the other side, is it negative there? It's positive. So therefore, I'm going to have to subtract 21 from here, and I'm going to end up with 16. Okay, so that square root of 16 is 4, so my radius is 4. Thank you for catching that for me. Okay. See, what we had is then we had a negative 21 to move that constant over to the other side. All right, so our center is at negative 6, 1, and then we have 16. Now, when you create for ellipses and hyperbolas, what you're going to have is that this is going to be up on the top, on the numerator of the fraction. All right, or the coefficient is going to be in the front, and then you're going to end up dividing by a number that is this coefficient times this coefficient. All right, so let's look at 4 real quick. All right, to complete the square for the x's, what do we take half of? All right, Reuben, number 4, we're going to complete the square on the x's. What do we take half of?
16.
16. So we get x plus 8 squared. All right, what's the third term that we've added when we add that completed square? 8 times 8. So therefore I have to put a 64 on this side. Now, what about the y? The y is plus 10, so that's going to be y plus 5 quantity squared. All right, and therefore my third term that I've added is plus 25. Now, what's the constant that's in problem 4? Is a minus 11. So if it's minus 11, I add 11. And now it looks like I've got what, 6, 7, 8, 90? That's 100. Isn't that nice? So at least it's a perfect square. All right, where's the center of this circle? Negative 8, negative 5. Okay, make sense? Okay, now that's what you're doing for squares. All right, let's see how much time we got. 5 minutes, good. All right, now let's turn to the ellipses and let's see what that entails. Turn to page 476. Now, let me erase this. Okay, now, on 476, problem 1, do you notice that you have a 4 in front of the x squared? Okay, and for the other x value, you have a negative 16. So if I take 4 times, okay, the first thing I'm going to do off the negative 16 is take a factor of 4 out. When I take a factor of 4 out, what's left? Negative 4. You see that? Now, I want half of the negative 4, which will be x minus 2 squared. Okay, so when you have the hyperbola and the ellipse, you're going to take out a factor, and then if they're nice, the remaining factor will be even, so all you have to do is take half of the remainder. Now, okay, now watch. What's the extra value now? It's 2 squared, which is 4 times this 4. So I've added 16, so I added 16 to the other side. All right, question on that? See, before, when we were doing this with circles, this was a 1. So all I did was just square this. Right, and really I should have squared it and multiplied by 1 to be able to do what I'm doing now. All right, now, look, what about the y in problem 1? All right, you notice that you have a 9y squared, right? So I'm going to take the 9 out, and I'm going to have what left on the y value if I take 9 out. Take 9 away from 90, or factor 9 out of 90, what do you get? 10. Half of 10? 5. So that's plus 5 squared. Now watch this. 5 squared is 25. Right? 25 times 9 is 225. So now I have to add a 225. Do I have a third term? Third term is 205. Right? So therefore I'm going to subtract 205. Now, I already know what's going to happen. If this comes out to be whole numbers, I'm going to divide by 36. So when you end up subtracting these, you get 36. So if I divide by 36, this becomes a 1. When I divide this by 36, I get a 4 on the bottom. Divide this by 36, I get a 9 on the bottom. Now, what's my rectangle? My rectangle has an x of 3 in each direction and a y of 2 in each direction from what center point? 2, negative 5. So I go 2, negative 5, and then I'm going to x direction, I'm going to go 3, and then y direction, I'm going to go 2, and I'm going to make my box. Because this is plus, that means I'm on the inside, I draw my ellipse. Had that been a minus sign, then I would have drawn the diagonals, and because the x was first, I would have had my hyperbola going in the facing opening on the x-axis. Okay, does that make sense? Okay, now, I hope that when you do this, and number one, it's going to take a little bit of time, but I hope that based on what I've shown you today, that you'll begin to say, oh, this makes sense. Okay. All right, thank you for paying attention. Any questions? All right, good.
Thank you.